coordinates. We usually use Cartesian coordinates x and y to present a point in a plane. However, polar coordinates r and theta are very convenient when you're dealing with circles, arcs, and specific type of curves, spirals, and so on. What is the polar coordinate? So if you have x and y on the plane, you want to find the r and theta such that r is the distance of the point from the origin, and then theta is the angle that a line segment connecting that point to origin makes with the x-axis. And theta is measured counterclockwise. Is representation, the polar representation of a point, unique? No. You can also assume that r is negative and then replace theta by theta plus pi. You can also other ways, any r and theta is also equal to r and theta plus. So r and theta can be also equal to r and theta plus 2 pi, and so on and so forth. So and it's not the unique representation, but for purpose of calculus 3, we're after this section is over, we always assume theta is between 0 and pi, and we assume r is positive. Let's do a few examples of polar and the conversion of polar and Cartesian coordinates. So let's plot the point given in the polar coordinates. First one is 1 and pi fourth. So how do we do it? We find the angle and the ray that makes pi fourth. Then on that one you basically separate 1. So this is 1, and then that would be the point 1 and pi fourth. What about -1 and pi fourth? So with -1 and pi fourth, you basically add pi to pi fourth. It's over here. Again, you separate 1 from the origin, and this one is the point. So here and here. How about 7 pi fourth? 7 pi fourth is basically over here, and separate 1 out of it, and it's right there. How about negative pi fourth? 1 and negative pi fourth. Negative pi fourth, again, the same thing as 7 pi fourth, and you separate 1, it's right there. So basically, you're using the, because all of the radii are 1, you're using a circle of radius 1, and those radii of the radii that separate the thetas, theta equal to pi half, theta equal to 3 pi half, theta equal to 5 pi half, and so on and so forth, and then you find the points. So these two are P1 and P2, then P3 is right here, and P4 is going to be the same thing as P3. So I talked about radii that signify theta, and I talked about circles that signify the radius of the point. And so these make the polar grid on your plane. And so you basically do use these pieces of lines that make the thetas for the signify the theta for you, and then you use the circles to signify different radius or different r's, and that makes the grid on the plane for you. So far we've basically tried to graph points in polar coordinates, and from there we kind of got an idea on how the Cartesian values of the point or Cartesian coordinates will look like. And so let's write this out. If x and y is the Cartesian coordinate, and r and theta is the polar coordinate for a point P, and then notice here this is r, and this is theta, and this is y, and this is x. So there's a triangle in there, and basically sine of theta is equal to y over r, cosine of theta is equal to x over r, and from there I can say y is equal to r cosine theta, r sine theta, sine theta, and x is equal to r cosine theta. And this is actually a formula that you can use to convert polar to Cartesian coordinates. If I give you polar right here, you can get the Cartesian values over there. So these are the input, outputs are x and y. How about the other way around? So the other way around, if I want to find if I have the Cartesian and I want to find the polar, and basically r squared is equal to x squared plus y squared, so r is the square root of basically r is going to be square root of x squared plus y squared, right? And that is coming from this triangle, because this was x, that was y, that was r, and so this is a right triangle, so it's going to be x squared plus y squared equal to r squared. Now how about the theta? And so what you can see is theta, and theta is the tangent of theta is y over x. So you can use arctan, and you have to be careful, because when you use arctan, only it returns to you thetas that are between negative pi half to pi half. So if you are not in that area, which means that if x is not positive, when you're using arctan, you have to consider that and add a pi, basically. Pi or pi plus 2 pi, depending on. But in this course, we are trying to stay for theta to stay between 0 and 2 pi.